Welcome to this explainer. Today, we're totally pulling back the curtain on the booming AI industry to reveal a massive, heavily concentrated physical reality that honestly almost everyone completely overlooks. We hear about these magical AI algorithms working in the cloud every single day, right? But we rarely stop to talk about the heavy, hot physical engines that are actually running them behind the scenes.
So, it brings up a fascinating question. Where does AI actually live? Let's dive right in. Now, you might be thinking of software companies in the US getting all the spotlight for designing these incredibly smart models. But the actual physical headquarters for this hardware? It's not Silicon Valley. No, the physical reality of AI relies almost entirely on the factories and tech of just two absolutely vital regions, Taiwan and South Korea.
Okay, here's our roadmap for today. We're going to cover the AI hardware revolution, the crucial difference between logic and memory chips, how the foundry and memory models work, the global and personal ripple effects, and finally what we call the single point of failure.
All right, let's jump straight into part one, the AI hardware revolution and the true physical reality of AI. We've got to start by shattering this illusion that AI is just floating code up in the cloud. The cloud is physical. It's made of metal, silicon, and endless miles of wire. What we're witnessing right now is the AI hardware ascent. This is the unbelievable rapid growth and absolute dominance of Taiwan and South Korea. They're the ones producing the exact physical components, literally the world's tiniest, ultra-fast transistors, that are required to make AI not just incredibly powerful, but actually energy efficient enough to run. Moving right along to part two, let's look at logic versus memory chips. Think of this as the brain and the filing cabinet. To really grasp how these two regions dominate, we basically need to split the anatomy of AI hardware right down the middle. Taiwan and South Korea have essentially divided and conquered the two halves of the AI brain. Taiwan is laser-focused on logic chips. These are the brains of the whole operation, the parts actually doing the active computing. Meanwhile, South Korea focuses heavily on memory chips. Think of this like the high-speed desk space or a massive filing cabinet that allows the brain to instantly store and grab massive amounts of information. And here's the catch. Modern AI literally cannot exist without both of these halves working in perfect, seamless harmony. And the sheer scale of dominance in this memory sector, it is absolutely staggering. Just think about this for a second. South Korean giants Samsung and SK Hynix control over 90% of the high-end AI memory market. 90%! So when you're asking an AI a complex question and it pulls data at lightning speed, it's almost certainly doing that using South Korean memory hardware. It's wild.
So how exactly did they corner a trillion-dollar market? Let's get into part three, the foundry and memory model, or what I like to call the master plan.
The secret sauce here really comes down to their highly specialized business models. Taiwan uses something called the foundry model. Basically, contract manufacturing is the name of the game. Companies like Taiwan's TSMC don't actually sell their own branded chips to you and me. Instead, they act as the ultimate high-tech printing press. They take these brilliant blueprints from companies like NVIDIA or Apple, and they actually build the physical chips for them, using incredibly advanced European tech to print microscopic circuits onto silicon wafers. They focus entirely on just being the absolute best builders on Earth.
Now, over in South Korea, they mastered a totally different but equally crucial technology, high bandwidth memory, or HBM for short. See, massive AI models require extreme data speeds. Standard computer RAM, it's kind of like a single-lane road. It gets backed up instantly. South Korean firms realized this and developed HBM, which literally stacks memory vertically to create this massive data superhighway. And to top it off, both regions use these advanced packaging techniques to essentially glue Taiwan's logic brains and South Korea's memory superhighways together into one single ultra-fast module.
We can actually watch this whole master plan play out in three very distinct steps. Step one, these companies aggressively shifted billions of dollars in investments away from older smartphone tech straight into AI hardware. Step two was the technical pivot. South Korean firms strategically prioritized HBM over standard RAM way before anyone else did. And step three, massive capacity expansion. By early 2026, the numbers show South Korea actually surpassing Taiwan as the top buyer of chip-making equipment as they frantically scrambled to build out more factories. It's just a highly coordinated strategy playing out right in front of us. Which brings us to part four, the global and personal impacts. The ripple effect of all this is just huge. Because look, this immense concentration of manufacturing power doesn't just stay neatly in Asia. The global ripple effect dictates the entire industry.
Since Taiwan and South Korea produce the absolute highest quality chips, the world's dependency on them is total. Huge international tech companies are literally forced to wait in line for production slots just so they can launch their new products. Economically, this has pushed Asian tech company valuations straight into the trillions. And geopolitically, well, these nations have become strategically vital. The modern world literally cannot function without their hardware.
But what does this mean for you personally? Well, pretty much everything. For your devices, it means your future smartphones and laptops will feature on-device AI running powerfully and totally locally right in your pocket. For your wallet, the monthly subscription price you pay for tools like ChatGPT, that's tied directly to the cost of this Asian hardware. In the job market, we're seeing massive global demand for engineers who specifically understand these exact chips. And finally, your investments. If you've got a tech-focused retirement fund, your financial future is deeply tied to the daily performance of these specific hardware giants.
But here's where things get a bit scary. Let's look at Part 5, the single point of failure, the Achilles heel of this whole system.
Despite all this incredible, mind-blowing success, this highly concentrated technological marvel hides a pretty terrifying physical fragility. The ecosystem faces some severe risks. First off, intense geopolitical tensions in the region could disrupt the supply chain at literally any moment, which would instantly trigger a worldwide technology blackout. Second, there's this constant looming struggle to find enough highly skilled talent globally to actually run these complex factories. And third, these massive giants actually rely on a delicate web of thousands of smaller, local regional suppliers for the highly specific chemicals and gases required for chip making. If just one link in that chain breaks, the whole thing grinds to a halt.
And honestly, it all boils down to the number 2. Just 2 global regions are currently bearing the massive resource brunt required for this whole AI boom. See, manufacturing these microscopic chips requires a truly shocking amount of electricity and water. Pushing all of this demand onto the infrastructure and local environments of just 2 regions creates a severe strain that, frankly, is incredibly difficult to sustain long-term.
Which leads us to a pretty chilling reality. Because so much production is heavily concentrated in just 2 places, a single natural disaster or a regional conflict would literally stop AI development globally. Think about that. We have essentially built the entire future of human technology on a massive, physical, single point of failure.
So, this leaves us with a totally critical, urgent question to ponder. As AI integrates deeper and deeper into our cars, our hospitals, our banks, and really every single part of our daily lives, how long can the global infrastructure safely balance our collective future on the physical hardware of just 2 fragile locations? Keep that in mind the next time you casually ask an AI a question. Thanks so much for joining me on this explainer. I really hope it completely changed how you view the physical world that's powering our digital future.